Now D and E are two special cases. D is the one where we have denominator with the radical there, not radical, denominator with a variable there. So we have some restrictions. From the domain we know x cannot be 3. So where there is x, there should be a restriction that y will not exist. So we draw something called asymptote there. We draw vertical asymptote. So here I say x here, y here. In the middle I'll say 3, which x cannot be. X cannot be 3. So we say dash dash dash, meaning x cannot be there. There will be a vertical asymptote. And then I pick few values to the right, few values to the left. It doesn't have to be 2. For this kind of graph, I suggest us to have 3 values on the left and 3 values on the right. It helps. Okay, so 3 values to the right of 3 will be 4, 5 and 6. And to the left will be 2, 1, 2, 1 and 0. Now let's put one by one. So if I put 0 there, I get 1 divided by negative 3. 1 divided by negative 3 is negative 0.3333. If I put 1 there, I get 1 divided by negative 2, which is negative 0.5. If I put 2 there, 1 divided by negative 1 will be negative 1. If I put 4 in there, 1 divided by 4 minus 3, which will be 1 divided by 1, which will be 1. 5 there will be giving me 2. 1 divided by 2 is half. And 6 there will be a third, which will be 0.33. Now, if you want a number in between these two, if you try number in between those two, like for example 3.5, if you put in 3.5 there, 3.5 minus 3 will give us 0.5. 1 divided by 0.5 is 2. So that will go up. And similarly here, if you were to try number between 2 and 3, let's say 2.5. If you have 2.5 here, 1 divided by negative 0.5 will give you a negative 2. So if you plot these points, this is how your graph will look like. Y equals 1 over x minus 3. And here, as you can see, your graph is trying to go closer and closer to 3, but there is kind of asymptote there. On paper, we'll draw a dotted line here going through 3, meaning that the graph is not allowed to cross those. Okay. So we will go for the table of values. We will go from 0 to 6. Okay. And then here at 3, as you see, it's infinity, meaning that there is a asymptote here going through 3. Your graph cannot cross that line. Similarly, here we have some restriction here. We know x minus 2, whatever is inside the square root, has to be greater than or equal to 0. So if you solve for x, we get x has to be greater than or equal to 2. So x can be 2 or more, but not lower than 2, because lower than 2 will give us square root to have a negative value, which is not possible. So for this particular type of graphs, I start at the minimum. 2 is the lowest number we can have. Then I go to 3. Then I can go to 4 if I like. But if I put 4 there, let's start with 2. If I put 2 there, square root of 2 minus 2 is square root of 0, which will give me 0. If I put 3 there, square root of 3 minus 2 will give me 1. If I put 4 there, which is fine, but I'll get a decimal. To avoid that, so for paper, I have to think backwards. What will be the x value when I have y equals 2? So in order for us to get 2 for the y, I need to get square root of 4. To get square root of 4, x value has to be 6. Let's try one more. If I want y value to be 3, I need to get square root of 9, because square root of 9 will be 3. In order for us to get square root of 9, x value has to be 11. And then if we try one more, if I wanted my y value to be 4, I need square root of 16 here. In order for me to get square root of 16, my x value has to be 18. Now let's plot this, see what kind of graph we get. We have we have y equals square root of x minus 2. Okay, so if we see that graph, then here when x is 2, y is 0. When x is 3, y is 1. When x is 6, y is 2. That point right here. When x is 11, y will be 3. And when x is 18, y is 4. Those are the points we will plot. Okay, so we can go from 2 to, we can pick up to 18 if we like. Okay, so again, the ones I want to highlight are this point, 3, 1, 2, 0. Then when x is 6, y is 2. When x is 11, y will be 3. And lastly, when x is 18, y will be 4. We don't need points in between. And that will be this graph right here.